All right, question number 17. We want to determine whether the mean value theorem applies to the function ln 12x on the given interval, 1 to e, and then if so, find the approximate points that guarantee the mean value existence. So the mean value theorem just says our function has to be continuous, and we can evaluate by plugging in a 1 and an e into this function. So we do know the natural log is a continuous function. If you want to check values with a calculator just to see if they exist, these two values do exist, but just to kind of show you, if you do ln, we'll just say 12 times 1, which would just be 12. You compute, you get a value, and then if we do ln of 12 times e, which is like 2.71 something, we'll get another value. So these are two values. It does exist. Since it's continuous, we know that we can take a derivative. So we will say the mean value theorem applies. Okay, and now from there, the mean value theorem says if we do the slope is going to be equal to the derivative at some point c. Okay, so we're going to do the slope. We have an ordered pair, not an ordered pair, two x values, 1 and e. So plugging 1 and e in, we're going to do the slope. We're going to say f of e minus f of 1 divided by e minus 1. This will give us our slope. We're going to plug in e and 1 into our function ln of 12x. So that's going to be ln 12 times 1. Sorry, I want to put the e first. Ln of 12 times e minus ln of 12 times 1. That's going to be our y values divided by e minus 1. Now, with properties of log, if you multiply, kind of like properties of exponents, you can rewrite this as addition. So we're going to rewrite this so I can simplify, so I don't have to use a calculator. So this can be rewritten as ln of 12 plus ln of e, and then you distribute this negative to both of these. So this will be ln of 12, and then it'll be minus ln of 1, and it's still over e minus 1. Okay, so in the numerator you have a minus ln of 12 and a positive ln of 12. Those two will cancel each other out. Then you're left with ln of e and minus ln of 1. Now these are two very specific values. Properties of natural log, ln has an understood base of e. So when you evaluate it at an e, which is not written, this is just equal to 1. And ln of 1, this is kind of like if you think about exponential notation, it has a base of e. What is that equal to? So when we, in algebra, we talked about taking e, raising it to some power, and it's going to equal 1. So the only thing when you raise something to a power that equals 1 is 0. So this is equal to 0. But let's just show you again with a calculator so you can verify it if you don't remember those properties. Natural log of 1 will give you 0, and the natural log of e should just give you 1. So when we evaluate the numerator, okay, here we have 1 minus 0, which is just 1. 1 over e minus 1. Okay, so this is the slope. Now we're going to do the derivative, f prime of x, and this is ln of 12x. So you do the derivative with ln is 1 over the argument times the derivative of the argument. So this will be equal to 1 over 12x times the derivative of this inside, which will just be times 12. That will give us 12 divided by 12x. 12 divided by 12 would go to 1, and so that just leaves us with 1 over x. So we're saying that our derivative is going to be equal to this at some point for some value of x. And we can see that since the numerators are saying that x has to equal e minus 1. So that's our f of c value. So f prime of e minus 1 is going to give us that slope 1 over e minus 1. For that tangent line to be equal, sorry, cannot see that. Tangent line to be equal according to the mean value theorem. So the point of x is going to be e minus 1.